don't know what we're going, but anyhow, we'll see how we can flow before the end of this course. Now, linear programming is based on mathematical techniques following three models. Model number one, graphical solution. You use a graphical method to solve a linear programming problem. Two, algebraic solution. You use algebraic solution to solve a linear programming problem. And three, the use of simplest algorithm. So these are the methods you can use for linear programming. Now, another thing I would like us to know here is that there are three steps for solving a linear programming problem. There are three steps for solving a linear programming problem. Number one step is this: identification. Now, identify the data of the problem. Try to identify what you want to do. Identify. It talks about decrypts and identifies the data of the problem. Identify, okay, what the problem is. Now, doctors will tell you, when you go to doctors and you tell them, I need drugs, they'll first of all ask you, what is wrong with you? Then you start telling them, explaining yourself. Now, in the process of you explaining yourself, you are assisting them in identifying the cause of the sicknesses in which you are suffering from. So that is what the doctors say diagnosis. They are diagnosing you. Then the engineers will say troubleshooting. They are troubleshooting you. The same thing applies here. You identify identification. Then two is formalization. Now, formalization consists of modeling the problem in the form of linear equation. It consists of modeling the problem in the form of linear equation. You bring the problem into linear equation. You draw linear equation from the problem into linear or linear equations or in equation or inequality equation to define the form of the different constraints. Then the third one is solution, which looks for the optimum to bring about the final solution. Programming solution. Now let's take this example, a linear programming problem. Let's say a FedEx delivery man has 6 packages to deliver to a customer in a particular time. Now, the delivery man has
Engineer, your phone. It's been muted. Been muted.
the link
All right.
the delivery man will have to do some calculations. Now, in his calculation, what is he trying to do? He wants to look for the shortest way in which he can deliver these 6 packages without saving enough fuel for himself, without wasting fuel. So this is the diagram you can see on my screen now. So the delivery house is located in point A, and while the destinations are U to Z. So you can see them there. Now in this place, the man will have to do calculation. How do I go? Let's say for example, you want to deliver a parcel from Lagos to Abeokuta to Ibadan. So what do? Now, will you want to move to Ibadan first? before going to Abeokuta, or from Lagos, you just take 3 and you move straight to Abeokuta, from Abeokuta to Ibadan. So you try to calculate the distance, the different, which one is shorter for you. So that is what linear programming talks about. And then you choose the shortest distance, because that by that you are saving cost. You are saving cost and maximizing the potential, maximizing profit. Now, the linear programming problem is the mathematical programming used to find the best optimal solution to a problem that requires a decision or set of decisions about how best to use a set of limited resources to achieve a goal. So when we talk about linear programming, um, problem is a mathematical programming used to find out the best optimal solution to solve the problem. It is a mathematical model or techniques for efficient and effective utilization of limited resources, like what I just said, maximizing cost and maximizing or lowering cost. Model components. Now, the model components of linear programming, number one is decision variable. Decision variables. Now, the decision variables, we talk about the mathematical symbols representing levels of activity of a firm. Now, number two, we have the objective function. The objective function. So, the objective function is a linear mathematical relationship describing an objective of the firm in terms of decision variables. Now, this function is to be maximized or minimized. Then, number three, we have the constraints. The constraints. Now, the constraints required or required placed or on the firm by the operating environment stated in linear relationship. And while we have the number four, the parameters, that's the numerical coefficient and constant used in the objective
Engineer, so any of yourself, you've been muted. Engineer Nathaniel, Please unmute yourself, engineer.
The thing is switching me off. Now, advantages of linear programming. One, it helps in attaining minimum use of productive factors. It helps in attaining minimum use of productive factors. Two, it improves the quality of the decision. It improves the quality of the decision. Three, it provides better tools for meeting the changing condition. It provides better tools for meeting the changing condition. And number four, it highlights the bottleneck in the production process. It highlights the bottleneck in the production process. Now, the disadvantage of linear programming or disadvantages of linear programming. One, for large problems, the computational difficulties are enormous. For large problems, the computational difficulties are enormous. For large problems, the computational difficulties are enormous. Two, it may yield fractional value answers to decision variables. It may yield fractional value answers to decision variables. Three, it is applicable to only static situations. It is applicable to only static situations. And four, it deals with the problem with single objectives. It deals with the problem with single objectives. Now, let's quickly look at the important definitions in linear programming. One, solution is a set of variables called solution. Solution is a set of variables. A problem, linear programming problem, if it satisfies is constraint, a constraint. Two is feasible solution. Feasible solution is a set also of variables x1, x2 to xn plus n. Now, linear programming satisfies its constraints as well as non-negativity restriction. And another way is optimal feasible solution. Optimal feasible solution. This is the basic feasible solution that optimizes the objective function. Then we have number four, unbounded solution. Unbounded solution is the value of the objective function that can be increased or decreased indefinitely. The solution is called unbounded solution. Now, let's talk about transport. Or before then, let's quickly, because of our time, let's quickly solve some problems on linear programming. Let's quickly solve some problems on linear programming. Okay, let's quickly see some problems on linear programming. So let's take this for example. So you get what I'm saying. A linear programming example. A company makes two products, X and Y, using two machines, A and B. Each unit of X, each unit of X processing, sorry, each unit of X that is produced requires 50 minutes processing time on machine A and 30 minutes processing time on machine B. Each unit of Y that is produced requires 24 minutes processing time on machine A and 33 minutes processing time on machine B. Now, to start with this, you say at the start of the current week, there are 30 units of X and 90 units of Y in stock. Available processing time on machine A is forecast to be 40 hours and on machine B is forecast to be 35 hours. Now, the demand of S is in the current week is forecast to be 75 units and for Y is 95 units. Company policy is to maximize the combined sum of the units of X and the units of Y in stock at the end of the week. Question number one, formulate the problem of deciding how much of each product to make in the current week as a linear program. And two, solve the linear program graphically. Now let's go by the solution I have here. Now before we go take it, let's take X to be the number of X produced in the current week and Y to be the number of units of Y cap produced in the last week. Then when we bring them to constraint, don't forget we have 50X plus 24Y is less than or equal to 4 multiplied by 60, and this is This is the working, this is the minutes of the machine time. So, and we now have for the other, we have 30x plus 33y is less than or equal to 35, then bracket 60, that is 60 seconds. So that's for machine B. So when we have this, we now have x is greater than or equal to 75 minus 30. So now that brings us to x is greater than or equal to 45. So production of x is greater than or equal to the demand 75. That is the initial stock we have, than 30, which ensures we meet demand. Now for the y, we have y is greater than and equal to 95 minus 90. So we now have y is greater than and or greater than equal to 5. So production of y meets the initial stock of 90, which ensures we meet the demand. So you could see from there, from the questions, we've been able to draw out equations, linear equations from this. So let's proceed further. Now to maximize the objective, our objective is to maximize. So how do we do that? So we go in by x plus 30 minus 75 plus bracket open y plus 90 minus 95. Then this will now give us x plus y minus 50. X plus y minus 50. So to maximize the number of units left in stock at the end of the week, so we have to come with the graph. So this is the equation, the linear equation we are able to draw out. So we plot our graph with it. We plot our graph with it. So solving it, we now have x to be 45 and y to be 6.25 with the value of objective function being 1.25. So you can see from here what we have. Our x is equals 45 and y is equals 6.25. So this is a problem of linear programming. Now, another thing I want us you to know is that types of linear programming. One, we have diet problems, we have manufacturing problems, we have transportation problems, and we have optimal assignment problems. And when we look at types of constraints, we have the specific nutritional requirements, the variable like work hour, material availability, production rate. The specific under the transportation of it, we have the specific supply demand, and optimal assignment, we have the number of employees, work hour of each employees, efficiency of each employees, etc. And the objective function for diet pattern, the cost of food intake, and for manufacturing problem, the cost of production, for transportation, the cost of transportation, and lastly for optimal assignment, the total assignment done. So this is what we have for today. This is what we have for linear programming. Please, let's try and lay our hands on problems involving linear programs. Then further, let's quickly talk, because of for the few time we have, let's talk about transportation problem, which I denote most time with TP, consists of determining how to route product in a situation where there are several supply locations and also several destinations, in order that the total cost of transportation is minimized. Now let's go back, flash our mind back to the first as example I gave of the FedEx delivery man. Now you will see that in a bid to reduce cost and maximize profit, so that is transportation. Transportation is a problem. It consists of determining how to route product in a situation where there are several supplies locations. Now, the thing is this: no company producer want to leave their goods in stock. No, every company want to ship it out, so that they know that when they leave their goods in stock in in-house, it might expire and they'll run at loss. So rather they want to ship it out. They want to let it go to the distributor, to the customer. So let it expire on their own hand, in their own hand. So when it is there, they are able to know that, oh, this goods is no more from us. Now, transportation problem, application of transportation problem. One, it minimizes shipping cost. It minimizes shipping cost. It minimizes shipping cost. Two, it determines low cost location. 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 3, it finds minimum cost production schedule. It finds minimum cost production schedule. And 5, military distribution system. Military distribution system. Now, the types of transportation. One, we have balanced transportation problem. Types of transportation problem. We have one, balanced transportation problems. This is where the total supply equals total demand. So when the total supply equals total demand, it is balanced transportation problem. And we have another one, unbalanced transportation problem. Unbalanced transportation problem. This is where the total supply is not equal to the total demand. The total supply is not equal to the total demand. Now let's look at, for example, we are JVS have tried to balance the problem, to try to balance the transportation problem or the online problem by making sure that every of our students are registered online. Let's say, for example, some are registered, some are not registered. We have lots of students. It will, that is what we now call unbalanced. It's unbalanced because some we are unable to meet with the requirements or the needs. Currently, we are able, DVS has been able to meet with the needs. So when it comes to the internet class of a thing, we can say it is a balanced transportation problem, or it is a balanced online problem. We are able to solve the problem. So every of our students are, both the BSc, the MSc, are currently online taking classes at their convenience. So it's a balanced situation. So when we say a transportation problem is balanced, meaning the total supply equals total demand. And when we say it is unbalanced, it means the total supply is not equal to the demand. Like if you watch this era of coronavirus, there are short of products in the market, so things are just going higher, higher. Why? Because the demand is more than the supply, so things are going higher. So the same thing happening here. Then let's look at the phases of solution of transportation problem. The phases of solution. Phase one, it obtains the initial basic feasible solution. It gives you the initial basic feasible solution. Phase two, it gives you or obtains the optimal basic solution. Phase one obtains the initial basic solution, feasible solution, while phase two obtains the optimal basic solution. So this is it. Then for the initial basic solution, we talk of the northwest corner rule, northwest corner rule, then the minimal method, the column minimal method, the least cost method, the Vogel approximation method. So for optimum basic solution, we talk about the stepping stone method, the modified distribution, which is I sometimes call Moody method. So please, this things has calculations, and for some of us, don't worry, we might not actually go into deep in the calculation. We'll just take the light one. But for some of us that are into sciences, like the engineers, please, I will advise you go do more to research, to do the calculations when it comes to linear programming transportation problems. It will help you in your field. The northwest corner method also it is called northwest corner method because it begins from the northwest of or upper left corner cell of our transportation table. We call it northwest corner method because it begins from the northwest or upper left corner cell of our transportation table. Now, we have the steps to take on the northwest corner method. Step one is construct an empty n by n matrix completed with rows and columns. Step two, indicate the rows and the column total at the end. Step three, starting with one and one cell at the northwest corner of the matrix, allocate maximum possible quantity, keeping in view that allocation can neither be more than the quantity required. Step 4, adjust the supply and demand numbers. And step 5, if the supply for the first row is exhausted, then move down to the first cell in the second row. Step 6, if the demand for the first row is satisfied, then move to the next cell in the second column and first row and go to step 4. And step 7, if for any cell supply equals demand, then the next allocation can be made in cell either in the next row or column. And while for step 8, continue the procedure until the total available quantity is fully allocated to the cells. So we have the least cost entry method. The least cost entry method takes into consideration the lowest cost and therefore takes less time to solve the problem. It consists of allocating as much as possible in the lowest cost cell, and then further allocation is done in the cell with second lowest cost cell, and so on. Now, this also has a step. The step one is select the cell with the lowest transportation cost. Step two, allocate as many units as possible to the cell. And step three, adjust capacity and the requirements for the next allocation. Then step four, repeat the process or repeat step one to three for the reduced table until the entire capacities are exhausted to fill the requirement at different destinations. So this is the Vogel approximation. Is a method allocation made on the basis of the opportunity or penalty or extra cost that would have been incurred if allocation in certain cells with minimum unit transportation cost were met. This is talking when it helps to take care of the basis of opportunity when some costs are omitted from the table. So these are the areas. Now, areas of application of uh, okay, the next one is assignment problem, and because of our time, we might not be able to go into assignment problem. But I just want to like thank every one of you again for listening to me today. And there's no assignment today, and for some of us, thank you for turning in your assignment. So I want to encourage you, please let's do with assignment. Go back to the assignment, practice the assignment that has been given you over time. And even if you fail to turn in, no problem. If the deadline has passed, no problem. But try to go through the assignment over and over, master them, and keep preparing for your examination. I want to say thank you for listening to me again. Till I come your way next week, do stay safe and have a lovely week ahead. God bless you.